Hey everybody and welcome to this YouTube video. My name is Lucas and I haven't done a lot of YouTube in a while, but I am doing a lot of electronics and software development stuff, so here I am back. Today we're gonna take a look at a project called OnjuVoice. And OnjuVoice is basically a way to take a Google Nest Mini, like one of these ones, and replace the main PCB inside with a custom PCB like this one, so you can have a fully private, fully local voice assistant that will be powered on HomeAssistant. We will take a look at this today. If you have never done anything with HomeAssistant before, or ESPHome is a new word for you, then this is probably not the video for you. Otherwise, stick around and check this out. You can find all the details about this on the project GitHub link that I will link up. Originally, OnjuVoice is both a hardware and a software solution for a completely custom voice assistant, but we are mainly using the hardware side of it and then creating a custom firmware with ESPHome. If you take a look at the GitHub, you can see these PCBs and there is not really a way that you can simply order them. What you need to do is take the plans from here and basically order them on PCBWay, but there is a one-click place to get to that order. Make sure you order them assembled with all the components on it, because otherwise you will have to do that yourself and you will need to source the components and do the PCB assembly yourself, where you should know SMD soldering, all these things. It's much easier and time saving if you just order the assembled PCBs here using PCBWay. The next thing that we need is a configuration for ESPHome, and for that we can find another GitHub repository called OnjuVoice Satellite. This one includes a fully pre-made ESPHome config that will pretty much give out-of-the-box functionality to this board. So what we're gonna do today is we are gonna basically take this thing apart and then take a look at how we get this board inside. And finally, we are gonna set it up with HomeAssistant. So let's get to it. Now, the first thing we need to do is actually, we need to get this little guy programmed. So when you order them, they basically come in a little bag like this. Usually you order either 2 or 5 assembled boards, and they basically have 4 LEDs and 2 microphones on them, and even the little USB port is already on there. Also, we have a ESP32C3 processor that will work with ESPHome. Alright, so let's get started. So the first thing we have to do is we need to go to the OnjuVoice Satellite GitHub repository and find the configuration file in ESPHome and OnjuVoice YAML. We will copy the whole file and then create a new file in an editor of our choice. I am using VS Code here and I have called it nabu4 since this is gonna be my 4th unit, and the wake word I am using is OKNabu, which is referring to Nabu-Casa, the company behind HomeAssistant. After we have pasted this in here, we need to do a couple of changes. So I usually have some other settings for Wi-Fi and for the OTA and encryption key. So I am gonna just delete out this first line here, and I'm gonna add my own settings that I would usually use. Here I'm gonna call this actually OnjuVoice 4. I'm gonna call it Nabu4. For Wi-Fi, I use my secret configuration. For the password, I'm also gonna use that. And for the OTA as well. And finally, I'm using Fast Connect because I'm using a hidden SSID, so that is relevant in here. Just gonna remove this kind of stuff. And I also use OTA is now defined up there. We don't need improv serial. I'm not a fan of that. We don't need the Wi-Fi IP, and neither do we need the captive portal. All these things are just additions that I'm not using anyways. So, but we do need though, if we search for API, in here I'm using an encryption, and we are using a encryption key here. All right, after we have set this up, we can save this file and we type ESP run nabu4.yml. Now what this will do, it will basically compile our firmware. Now we need to be a little bit quick because we're gonna take this board while our project is compiling, and we're gonna hold down this boot button right here, you know, the one that says boot. Gonna hold it down and connect the USB plug to my computer. So now that we have done this, we can go back to our coding, and you know, it actually asks me now if I want to select the USB modem, which is a bit hard for you to see right now. It is about here, and we're gonna press 1, and we see an upload process running. This takes a couple of seconds, but it's fairly quick. And after that's done, of course, the board doesn't boot because it's now kind of stuck. So we'll just quickly press the reset button here. That will actually close the serial port. So if we just quickly reconnect it, we should actually see it light up yellow like this and blink at us, so we can see that it actually wakes up and the board works correctly. So I just want to mention quickly that I had some of these boards actually having some defects. So I would really double, triple check on all of those little components right here. I had one of the capacitors around the power supply that was standing up vertically. So you probably do want to check this. All right, now that we have actually done the programming of this, we are pretty much ready to build this thing into our Nest Mini. And that is what we're gonna do now. So let's get this unboxed. And this was used by another guy that I have been buying this from. We can actually use the original power supply, so don't get rid of that yet, but let's get rid of it for space purposes. All right, so the first thing we need to do when we flip this around, this only works with the second generation of Nest Minis, so the ones that have this mounting hole here for a wall mount. If you don't have one of those, I am afraid you have probably gotten the wrong one. So we can take a little piece of plier and get out this rubber plug. Make sure to keep this. And then there is exactly one screw in here. I hope you can kind of see it. We need a Torx screwdriver like this one. Not sure if that is actually too visible. And we can open up this screw in here. Make sure to store them somewhere. And after we have done that, we need to twist into this direction. So and I told you the wrong one, did I? Yes, no, I didn't. This direction, basically clockwise, just a quick turn, and then very carefully lift this off. I say very carefully because there is a little flat cable on one of the sides, which we do want to detach now. So you do that by opening up this little connector here. We can lift this flap, and then gently take out the connector cable so you have that detached. Put that aside, we will need it later. And see that there are 4 more screws around here that we need to take out now. After you've removed those 4 screws, we can actually take off the speaker, and you can see that there is a connector plug right here that we can open up. This unit does actually look quite a bit different from the last one that I opened, but it looks like it will still fit exactly to this. So we take out the speaker, that is fine, and now we have 5 more screws that we need to open. Keep in mind that this top one here is the shortest one of the 5. Alright, so in this one actually all of these screws seem to be the same length. So the next thing is we're gonna open this up. Just take out this middle plate. On this specific one it is actually completely out of metal on this side. Careful with these pieces of paste, they are very disgusting and sticky. So we do want to get rid of this heat paste here, because it's just going to make everything else dirty. Now we can take a look at our mainboard here. We do want to get rid of the cable because we still need that. So we need to open up this little plug and carefully push out the cable. We will take that aside. And now what we need to do is we need to actually take out this PCB. Now there's 3 points where this PCB is glued in, where there used to be 3 microphones inside of the Google device. And we will take a little bit of a screwdriver here and get this out. You can see on the replacement board there's only 2 microphones, 1, 2 here, but they aren't in the same locations as in the original Nest board. Keep in mind this is not the nicest way to do this, but we also don't need this board anymore, so it's fine. Alright, so this came off with the entire installation very clean here. That's super. That didn't went that easy on the other board, so you will either have to cut this strip or just lift off the rest here. Now, this is great. We have the original main board, and the last thing we really need from it are these 3 gaskets. Now, if you take a look at this, you can see that there is holes in the PCB where the microphones are. This is where sound enters the microphones, so you definitely do not want to clog them. But here we have those gaskets. There is a piece of sticky tape around them, and then there is a little mesh in here. And we do want to now try to be super careful about prying these off with our pliers and placing them on the new PCB, because we still need it to stick in those places. Okay, great. Now we have placed all of the 3 gaskets on the new board, and we are ready to put it back into the actual housing. So we will just do that. Make sure to align those holes also perfectly well. That will heavily influence the quality of your experience afterwards. and it will all snap into place, and we will press it on. Perfect. Now is a good time to actually take our cable here and move it back into the little slot on the new PCB. So make sure that flap here is open and we put it in the right way, so you will be able to put it all back together. Notice that this will not go as far in as it did before, because that plug is a little bit finer, but make sure that that black line is super parallel to the plug. Now with this particular device, when you take a look at this base plate, you can see that there's a lot of metal underneath it. So what you really want to do is, if you have such a base plate, you want to cover this with some kind of heat resistant tape. For this, I simply use Kapton tape, like you would use it for 3D printers. So if we take a look back at this, we are gonna move the stuff aside and we're gonna take a little bit of Kapton tape. Actually, first I wanna get rid of this little notch here. And then we're gonna take a little bit of Kapton tape that we will move over the center part of the thing here. Like so. We will poke some holes for the screws. And wrap the rest of it around here. This is really pretty important because otherwise you might end up with a device that will not boot. All right, once this is done, we can put this back up here. And put the screws back in. Now, because of the fact with the base plate, I do want to quickly make sure that it really works. So we will just quickly connect the ribbon cable to the base plate. Close the connector and take our original power supply cable, which I have already plugged in, and quickly connect it here. And indeed, we can see it wakes up correctly. So, knowing that, we can get rid of that again and open up our little connector here. Then the next step is to put back the speaker. Make sure you connect it here. And of course the speaker part of the speaker goes back in. We realign that in the same way that it used to be in. And continue adding the screws back. After we are done with that, we put back the bottom plate, we need to again reconnect the little ribbon cable here. And then close the connector. Put it back together. And then twist it back into place. Remember, you need to twist counterclockwise, so you set it on a little bit against, like clockwise, and then you twist it counterclockwise to close it up. One final thing we need to do here is add the last screw, which goes into the back. And finally, we can put back our little rubber plug thingy. There we go, and it's fully assembled again. So let's give it a final test. And we can see it wakes up, so that is great. So the next step that we actually need to do is now connect our little new device to an actual Home Assistant instance. One other quick note, if you look at it from the top, you can see that you can still touch the sides and you can actually adjust the volume of the output. And if you would touch its center, it would trigger a actual voice activation, but we need to connect it to Home Assistant first. Also, I noticed that the center touch only works if you are in mute mode, which it will actually be if you press mute. You can see that there's no purple activity LEDs right now. If I turn mute off, you will have purple activity LEDs indicating that the device is listening. Now let's actually add our device to Home Assistant. So to do that, we are going to open up Home Assistant, go to Settings, go to Devices and Services, and we will find our new device that is called OnjuVoice 4. We click on Configure, Submit, enter the encryption key, and we have configured our voice satellite. And we're done. Basically, we can now use our device. So we'll quickly try that out. Taking a look back at our little device here. Okay, Nabu, turn off living room. And it works.
Turned off the light.
Absolutely perfectly. So let's revert that again. Okay, Nabu. Okay, Nabu, turn on living room.
Sorry, I couldn't understand that. Turned on the light.
Now, you should not have a lot of Nabus in the same room. That's probably not too clever, just like I did. But this device works, and that is really great. So I hope you enjoyed this video and you could follow along. If you have any questions, put them down in the comments. Thanks for watching. My name is Lucas, and see you again on this channel, maybe in the future.